The reason why we call it a micrometer screw gauge is because it can measure up to 10 to the power minus 6 meters. It's also written as 1 micrometer. The symbol mu is for micro. Now, this instrument can be used to measure the thickness of a string, a wire, a paper. It's pretty useful to know how it works. If we see the micrometer screw gauge, it has got readings all across this scale which we can turn, which we call as the circular scale. And if I open it out, we can see that there are markings on the horizontal scale as well. So today we're going to look at how to look at a zero error, what it means, and how to correct for a zero error. Right now what I have done is I have aligned the zero of my circular scale with that of my main scale. So when I have aligned, I made sure that it is in one straight line. When I look for a zero error, there are two ways of looking at it. The first one being, I have the zero of my main scale, the zero of my circular scale is on the straight line, like how I have shown. This would say no zero error. But if the zero of my circular scale is either above that of my main scale or below that of my main scale, then I have got two different types of errors. So quickly, let's have a look at it on the micrometer screw gauge. Now, if I close the micrometer screw gauge, so I'm closing it down, as you can see this gap here closes completely, and I have my zero which is slightly above that of my pitch scale or my main scale. So here this should be clear enough. We can see that the zero on my circular scale has gone up. The error in this case, the error is positive, meaning the zero has moved up, but I need to correct this error by bringing it down. So my correction, or the error correction, is negative, meaning from my value I need to take away my zero error, which I'm writing it as ZE. In the next case, I can see that the zero is below my zero of my main scale. So for example, as you can see here, this line represents the zero on the main scale. The zero on my circular scale is way below it, which is the second case that we have seen. So in this case, since it is below, my error is negative. Error is negative, and the error correction would be positive. Meaning from my value I need to add this to push the zero up to the starting point.